Hey Dragons, I wanted to give you a quick overview of what these letters A, C, and D do to the parent quadratic. A is called the coefficient. It is the number in front of the x or in front of the x squared, depending upon which form you have. Let's look at what happens if A is positive. If A is positive, the parabola opens upwards. It's going to be smiling at you. It's going to be a smiley face. I want to quickly show you through Desmos.com what happens whenever you change the value of A. Right now you see the parent, and what I'm going to do is I'm going to take a look at what happens whenever A is going to be bigger than 1. So if I come over here and change this to a 1 and change this to a 10, look what happens. It actually gets narrower. Speed this up a little bit, you can see the action happening at a faster pace. So this is when A is greater than 1. You can see that it is getting narrower. Now, look what happens whenever I change this and make A go between 0 and 1. So I'm looking at a fraction between 0 and 1. Look what happens to the parent here. What's happening? Getting wider. Okay, so whenever it gets, whenever the value of A is between 0 and 1, it's going to get wider. You notice right here it's going to hit 1, it's going to be the parent, and now the value is less than 1, noticing that it's widening up. So this is whenever A is positive. We have these parabolas and they're smiling at us, and that's what happens. So if you want to jot this down, or if you just want to have it, if A is greater than 1, what happened whenever it went bigger than 1? It got, it got narrower. And if it was between 0 and 1, it got wider. So hopefully now what we can do is, without graphing, we can say, hey, what's the value of A down here? And we'll say that, well, A is the coefficient of x squared, and it's 3, and 3 is bigger than 1, so right away we're going to say, hey, this thing is going to get narrower than the parent. And if I come over here and I look at the form, what's in front of the parentheses? That's the A in this form right here. A is going to be 1/4. Well, 1/4 will fit right here, and that means it's going to get wider. Okay, that's if A is positive. Now, let's take a look at what happens whenever A is negative. So when A is negative, we're going to have the reflection of the parent. So if I come over here and change it, we're going to have the reflection of the parent. Let's come over here and let's look at some values. If we have values less than 1, so I'm going to go from 10 to a -1 on this. Let's animate it and let's see what happens here. So if I go smaller than -1, look what's happening to my graph. It's getting narrower. Okay, let's speed this up a little bit. You can see, that may be too fast, that it is getting narrower. So if I'm less than -1, I'm going to get narrower. All right, so let's see what happens whenever we look at values between I don't know, 0.001 and -1. That first one is just not cooperating. Let's animate that one. That didn't catch, did it? Come on. I don't want a -0.001. Come on, do it this time. Oh, I know what happens. I've got to put my -1 first. Because that's smaller. Come on, math teacher. Oh boy, I need to be singing a song or something right now. Killing time. Will that do it? There we go, finally. Look what happens. getting wider. So if I'm between -1 and 0, and get wider. Okay? So, to summarize here, if A is negative, it's going to open downwards, it's going to be a frowny face. And if it's smaller, A is smaller than -1, it's going to get narrower. And if it's between -1 and 0, it's going to get wider. So, can we just look at this and see which one is going to affect wideness and narrowness? We look right here. A is -2. And -2 makes sense right here. This one's going to be narrower. And over here, A is going to be a -1/8. That makes sense right here. This guy's going to be wider. Okay, so the effects of A. Now, let's take a look and see what happens whenever we go to looking at C. Let me see if I can get this set back up to where it makes sense here. And let's see, I'm going to run here. Let's stop that one. Let's put it right at one. Okay, and let's go back to the parent. So let's pull this guy back down right here. All right, what happens whenever we mess with C? So if you notice right here, C is changing. What's it doing? It's moving left or right, isn't it? Okay, so whenever you change the number or affect the input by subtracting a number from X, you're going to get a shift to the left or to the right. Oh, got close. So, let me get the right paper up here. If we are looking at the effects of C, if you're going to subtract C, we're going to translate right. And if we're going to add C, we're going to translate left. So as I take a look at that, remember, it's C is inside the parentheses, but it follows the X. So if I look right here, in this case, C is 2. But I'm subtracting it, so I'm going to translate this guy right. And you can verify that on your calculator. 4 is a value of A. Remember, that's going to be wider or narrower. And we'll talk about this in just a second. What's the value of C over here? It's 1/2. Okay? And not C, that's A. C is going to be 3. Sorry about that. C is 3. This is A. So we're going to add that, so this one is going to be a translation to the left. And finally, if we take a look at our value of D, right here we have our parent. Once again, let's animate that and see what happens. If we change D, oh my goodness, we're in the elevator now. Going up and down, up and down. So this one is actually, to me, is the easiest one. This number right here at the very end, it's just tagging along. It's the caboose. It's going to translate up or down. So as we take a look at this, if D is positive, we're going to translate up. If it's negative, we're going to go down. So as we look at these problems, we look at the tail end. I'm adding 7 after the x squared. And so this is positive, so this one will go up 7. And if I look right here at the very end, it's not inside. The value of D is a -4. We're going to translate down 4 units. So over here up 7, over here down 4.